Good evening. Thankfully, I'm not the last person standing between you and your beer, so that makes me much more comfortable standing here. I'm not holding you back. Just a show of hands, how many people here use Gitops in the production environments? OK. How many folks know Gitops or heard the term Gitops? OK, perfect. So we will start from a point where it makes comfortable for the whole audience to know and understand Gitops. But before starting with Gitops, the required disclaimer. This is the same standard disclaimer. I want you all to memorize this because security guards aren't going to let you out until you say this verbatim. So please make sure you memorize this. OK, so to get started, a bit about myself. My name is Pradeep. I've been in software engineering for almost 23 plus years now. I'm showing my age. I started my career at Logica, where I built the real-time gross settlement system for India. I also built a bunch of retail banking and core banking systems. I also built one of the first mobile banking applications in the Middle East for a pretty large bank in Saudi Arabia. Post this, I worked for Dell, where I built Dell's e-commerce systems when they were going global. Dell.com, Premier.Dell.com, those are some of the large e-commerce systems competing with Amazon at that point in time in terms of revenue. Post that, I worked for UE, where I built a cloud-native insurance platform from scratch. It was a pretty amazing experience. And right now, I work for VMware doing what I love doing the best, which is empowering organizations and developers knock the ball out of the park on a daily basis with tons of products. I'm also the founder organizer for Cloud Native Brisbane and the founder organizer for Sunshine Coast.NET Users Group. Both these are amazing communities, amazing people. We hold our meetups on a monthly basis. Please feel free to check us out on meetup.com, and please do subscribe. Those three are the endpoints at which I'm available. I'm happy to continue these conversations. Post the discussion, please feel free to hit me up at any of those endpoints. No, that's a pretty long introduction. OK, in terms of agenda, we'll start off a bit gently. This session is, I got 22 minutes to go. We'll start off with a gentle introduction to DevOps. We're not going to go deep into DevOps, but we'll look at what's DevOps from an overall perspective. We'll look at some challenges of DevOps, which sort of helps us to lead gently into GitOps to understand what's GitOps. We will have an overview of GitOps and sort of look at the GitOps principles. And we'll also go through a simple GitOps process. And then we will die by the sword by trying to do a live demo of running a GitOps process through TAP, and hopefully roll forward a new application as well as roll back an application, all in 22 minutes. So let's see. OK, so DevOps. I don't think so I need to explain DevOps. Most of you would be using DevOps on a daily basis. But DevOps is, for me, primarily, it's a combination of cultural philosophies, processes, and tools that helps organizations develop and deploy applications and services. It enables faster velocity. It enables organizations to compete effectively in the market. It enables them to have amazing amounts of agility when used the right way. It helps organizations to evolve and move at a faster pace. But DevOps also has certain challenges. But the primary perspective from where DevOps really works is it breaks down silos. At the heart of DevOps is people and processes. A lot of people conflate DevOps with the tools. But in reality, DevOps is all about people and processes. It's all about breaking down silos, enabling communication across the whole organization, and enabling amazing collaboration between all the people in the organization. And when people are able to collaborate and talk to each other, have open communication, that's when magic happens. And that, for me, is DevOps. It's not about the tools. It's not about all those amazing CNCF pictures that you see. But it's all about people talking to each other, having amazing collaboration, and making sure they set up each other for success. Right? Now, at the heart of every DevOps process is what we generally call as a CI/CD pipeline. Now, this is something that I think you have all been bored of seeing for the past day and a half now, because this is something I think that we've been showing in almost every session. Now, in a general CI/CD process, there's a huge difference between the continuous integration parts of the pipeline and the continuous deployment parts of the pipeline. In the continuous integration parts of the pipeline, it's primarily developers and QA and a bunch of other team members working through and ensuring that they can develop an application and sort of toss it across a park to the operators. In the continuous integration pipeline, the primary focus is on velocity of change, is on making sure that changes can happen faster, is on making sure that experimentation can happen, is on making sure that risks can be taken. That's a primary focus of a continuous integration pipeline. The continuous integration pipeline is all about change. It's all about taking risks. It's all about enabling velocity and speed, right? That's what the continuous integration pipeline is. Whereas the continuous deployment pipeline is all about stability. No production operator wants change on a daily basis. No production operator wants things to be changing every other hour. There might be people who proudly proclaim that they deploy 10,000 times a day, but do they really deploy 10,000 times a day? And are the production teams happy supporting those sort of deployments? That's a huge question mark, right? Now, these two are orthogonal concerns. Think about it. There are a bunch of team members who want to move faster, who prioritize velocity, who prioritize change, and there's another bunch of team members who are prioritizing stability, who are prioritizing a slower pace of change, who are prioritizing gated ways of getting things into an environment maybe. So these, for me, are orthogonal concerns, which for me is one of the biggest challenges that we have from a DevOps perspective. This is something that we all generally encounter, and this is what it leads to. Developers are happy writing code, creating a release, throwing it across a wall, and then operators left handling the baby, right? So one of the first things that we have, as I was talking about, is overcoming the dev versus ops mentality. DevOps is great. As I said, it works amazingly well when organizations talk to each other, when people within the organizations are empowered to take decisions. But these are some of the things that you need to be really concerned about. So one is making sure that you can overcome the dev versus ops mentality, when you can ensure that you can enable rapid changes to an environment, while at the same time ensuring that there is stability. The second one is emphasis on tools. While DevOps has been amazing, it's also led to a huge proliferation of tools. There has been an amazing bunch of tools that have come out to the market, which enables some amazing functionality out there. But this culture between the continuous integration parts of the pipeline and the continuous deployment parts of the pipeline have also seeped into these tools. There are a certain bunch of tools which enable the same faster velocity, amazing changes, acceleration in terms of making changes to systems. But at the same time, there are certain other operations tool sets which focus on stability, which focus on slowing down things. So there is also an orthogonal issue over here in terms of the tool set too. And that's something that you need to be very, very aware of. Then team ownership for deployments and releases. Again, a show of hands. How many folks here are very clear about the distinction between a release and a deployment? Okay, so in my mind, a release is a set of features that get bundled in for customers to use, whereas a deployment is a transfer of all those features from one stable environment or one controlled environment to another controlled environment. Not every release results in a deployment. In a lot of cases, a bunch of releases can result in a single deployment. And in some cases, some releases may never get deployed, completely possible. So we need to be very clear of that distinction between a release and a deployment. And an understanding of that is key to understand why the CI parts of the pipeline are very different from the CD parts of the pipeline, right? And again, ownership. So who owns a deployment and who owns a release? Generally, developers are more focused in terms of releases. Developers want to ensure that there are a bunch of prioritized features that they want to bundle into a release, and that release is done, and they are done with it. Yep, feature 1, 2, 3, 4, it's all in this release, I'm done with it. But then the operations folks have to worry about, hey, can I package this release as a deployment? Can I deploy it? Will it be stable? Will I be able to manage it? Will I be able to operate it? Will I be able to take care of all its hygiene? And will I know and understand it? So again, there are issues which need to be overcome in terms of working through in a DevOps environment. And the last one is very specific to environments which use Kubernetes. One of the best things about Kubernetes is the fact that it uses a reconciliation engine, which reconciles between desired state and actual state. And that reconciliation engine is amazing. And that makes Kubernetes an amazing system to use. You have to tell Kubernetes what needs to happen, and it ensures that it happens. It doesn't care how it happens, but if you declaratively say that this is what I need, Kubernetes makes it happen, right? But while Kubernetes does that, it does not keep track of all the changes that it had to go through to get you to that end state. You tell Kubernetes, hey, I need a deployment with a replica set with 5 pods running across, right? Kubernetes ensures that it gets 5 pods up and running. But all the changes that it needed to do to get those pods up and running are not being tracked. There is no way you can have that level of history to say what happened and how did I get to these 5 pods. There are certain hacks which are enabled in Kubernetes in terms of using annotations, etc., when you can put in a trace of what happened in the past, but Kubernetes generally does not allow you to maintain history. And that's a gap that organizations need to be very aware of. And this is the reason why it's very, very important. For people who attended the keynote, I saw a quote which said, chaos leads to stability. And that sort of really resonated with me. Chaos definitely leads to stability, but only if you can learn from that chaos. If you don't even know that chaos happened, or if you can't go back and deep dive into that chaos, you learn nothing from it, and it definitely does not lead to stability. There's more chances of that chaos happening again and again if you do not learn from that particular chaos. And that's the reason why it's very important to know and understand why something happened, and what can you do to be able to prevent that from happening again? Or if something good happened, how can you ensure that the same thing happens again? Or how can you ensure that you can repeat on it, right? So this for me is the first part of my session, where we talked about DevOps as a general introduction and sort of the challenges of DevOps. So how many folks over here use DevOps on a daily basis? Show of hands. 1, 2, wow. Okay, that's cool. And how many of you amongst you think DevOps has been very effective for you? Okay, that's good. Cool. I just got 2 hands, and it was 50-50 in terms of how useful it's been. Okay, so the next part of the session, again, a gentle introduction to Gitops. So the whole concept of Gitops is to cover up for these deficiencies that we have within DevOps. And Gitops, in reality, is primarily just a set of principles. It's not a tool set. It's not a bunch of tools that you use. But basically, Gitops is a set of principles for operating and managing your software systems. And it uses Git as a single source of truth. And it uses declarative infrastructure and applications. I marked these items in green because they are key. The primary part of Gitops is it's a set of principles, as I said. It's not tools, it's not tool sets. The other parts of it is it's a single source of truth, and it uses declarative infrastructure. We will look at each of these in detail. I'm sort of running short on time. So these are the 4 Gitops principles. The first one is it's declarative. Gitops emphasizes declarative infrastructure. In fact, Gitops emphasizes declarative everything. In a Gitops process, you use infrastructure as code, you use policy as code, you use compliance as code, everything is code. Gitops makes sure that only if you can do a declarative system can you manage things as code. In Gitops, you don't do a kubectl apply ever. That's the whole idea about using Gitops, right? And everything is managed. And once you have your declarative state, your desired state being declared, being in declarative manner, then you can version control it. And because you can version control it, you can have immutability, you can have versioning, and you can history. If your desired state is expressed declaratively, you can comfortably use a version control system to manage it, and you can have versioning and history. This desired state is automatically pulled by software agent. Gitops highly emphasizes the use of automated agents which pull this desired state. Again, there is a huge difference between pull versus push. Gitops emphasizes on the pull aspects primarily because of 2 reasons. One, the environment pulls this configuration and deploys it. The environment is in a better state to know when it should be applying these changes, and that's the reason why it's a much better state rather than it being pushed. Maybe the environment is not ready to accept those changes, and maybe it's not an ideal time frame for those changes to be pushed into the environment. The second part of it is secure credentials. Because changes are being pulled, the environment does not need to share its credentials, and it gives rise to a much more secure solution. The last one is it's continuously reconciled. These automated agents don't just pull this configuration change once. They rather continuously run through. They do drift detection, and whenever they understand that there is a drift, they automatically reconcile and make sure that actual state and desired state match each other. These are the 4 Gitops principles. In terms of what you get out of the box, as I said, Gitops emphasizes using declarative code. So everything is managed declaratively. Your code, your policies, your security, your configuration, everything gets managed as code. Since everything is managed as code, you use Git as a single source of truth. Again, you can use any version control system, SVS, TFS, SVN, or any version control system that you are comfortable with. You get full audit trail for compliance and stability, purely because everything is version controlled. Then you get autosync, purely because you have autonomous agents which continuously sync these changes and manage desired state. And the last one is security, because your security is also managed as code. Your security shifts left because you start to think about security right at the beginning because you're managing it declaratively. You're no longer going and clicking some boxes to enable endpoint scanning, maybe as an example, right? So this, for me, is what you get with GitOps out of the box. So what happens in a general GitOps process? In a general GitOps process, the application developer and the platform developer initially work through on figuring out what's the infrastructure that's needed and what's the application code that they need to develop. And they both work together on creating the application repo and the configuration repo. GitOps also emphasizes on ensuring that you follow cloud-native principles. So your application is separated from its configuration, and the configuration needed to host your application is maintained separately in a different Git repo. So the developers work through the application repo, they make application changes and push it through. It runs through the CI/CD pipeline. It runs through the CI pipeline, generates a container image, and pushes it to the container repository. And once that's done, it creates a pull request where it updates the image SHA. And once that's done, the operator can then review those changes, perform a pull request, and the GitOps agent, once it's approved, the GitOps agent automatically pulls a new configuration and deploys it to the environment. So this, for me, is a whole GitOps process. Again, everything happens declaratively. There is no kubectl push. In this demo, you will not see any YAML that I'll create. Everything will happen through source code, right? OK, so let's run through a quick demo. So what we're trying to do is work through an application. Can we go back to the slide, if you don't mind? The application that I'm trying to do is a weather forecasting application. I believe Singapore is buying a new supercomputer which enables Singapore to tell its weather better, which is always hot, muggy, and wet in the evenings. I thought maybe I could replicate that on the way in. Can you share my screen? I need to rush through my demo. It's fun. OK, so this is people in the back. I know it's hard to see, but I've already created the application. I'll just do a run locally. This is on my local laptop. OK, it worked. OK, so what's the weather like in Singapore? That's fast. What's the weather like back home? Whoops, I got the name wrong. Yeah, weather's good back home, and it's thunderstorm with rain. OK, so what we're trying to do now is to sort of push this application to production. This is running locally on my system, and I'm not writing any YAML. All I'm trying to do now is to sort of do a change. The version of this application, I got 7 more minutes, is 1.7. And let's assume the blue color looks bad. You can't see what's within it. Let's go ahead and make that change. So I'll go and change the version to 1.8. And I'll change the color to black. Hopefully, black should be fine. OK, and I will do a simple shortcut in the interest of time. What I'll do is, rather than doing a pull request, I will directly commit it to mainline, which is sacrilege. I shouldn't be doing it. So I would directly commit it to main, and that's all I need to do. So if I go over here and check for Tanzu apps workload, yep. OK, so this workload is right now being built and deployed. While this is being built and deployed, can we please go back to the slide? Thank you. So while that's happening, we'll just look at what we did so far. What we've done so far is to create a simple application. The application workload has the necessary YAML. It was created through the accelerator, which David Lloyd and the others showed previously. And that accelerator has all the necessary workload YAML to enable it to be pulled through the pipeline. And what it basically does is I've checked in the code. And once I check in code into Git, Tap uses a Gitops process to watch the Git repository. And once it watches the Git repository, it notes that there was a change which was made to code. It automatically pulls down that code. It builds that code, and it runs through the CI pipeline, builds the code, creates an image, and checks it into a container registry. I'm using an Azure container registry hosted in Australia. And then once it's done, it does a config update into my Git repository. I will show you the 2 Git repositories that I'm using. Can you switch back to my screen, please? So, nope, I need to use this one. So this is a supply chain which is running. So this is my config repository. This is where, once the application is built, it would create, and this is the only time you would see a YAML in this demo, and I'm not generating this YAML. This is auto-generated. So this is what Tap does. Tap allows conversations in terms of higher order deliverables. We're looking at a delivery YAML which has been generated, and this is a Knative service. It allows for serverless deployments, wherein I can scale it up and scale it down to 0 automatically. So Tap would go ahead and generate this as part of building it. Let me just check if it's been complete. I've got 3 minutes to go. Yeah, the build is complete, and you can see that it's over here. Let me increase the size. It's gone ahead and opened up a PR for me with the changes that I've created. Can people at the back see? So over here, it's run through the CI pipeline, created the container image, checked in the container image, created a delivery YAML, and it's running through still. So it's gone ahead and it's created the PR for me. I will just open up the PR in GitHub and approve the PR, and it should automatically deploy. Yeah, the pull request is over here. You can see that it opened the pull request 18 seconds back. So this was a change. The pipeline was pretty fast, actually. It basically created a new container image. You can see that this was a previous container image, and it created a new container and updated the delivery YAML with the new container image over here. What I'll do right now is to go ahead and I've reviewed the changes. I will merge this pull request. Confirm merge. And right now, it's going through the second part of the process, which is the CD part of the process, wherein it will pull this new container image and deploy it into the cluster. And it should be complete. Yeah, so let's this is right now running. If you see the URL up there, it's not running locally. It's running on a Kubernetes cluster. And the color changed to black. And the version is 1.8. And that's just on time. I got 1 more minute to go. So that's Gitops in a nutshell. I didn't write any YAML, which I'm proud of. Developers need not write YAML. Let me say it very, very proudly. Developers need not bother about writing YAML. It's up to platform operators and others to be doing that. Developers need to focus on code, and that's what Tap enables you to do. Developers focus on the fact that they can knock things out of the park by writing amazing code and delivering applications out there which wows customers. And platform operators do what they do best, which is in setting up platforms which enables development teams to do what they do best. right? So thanks for your time. Appreciate your time. And I've got 19 seconds to go. So, yep. Can we go back to the slides, please? Because I need to show you the thank you slide. We don't have enough time to do a rollback. A rollback is very simple. A rollback just involves doing a git revert. And if I do a git revert, it will just change back. And it'll create one more new PR and revert it back to the old container image. And I can deploy it. And I did a revert previously. And that's how we would perform a revert. OK, thank you, guys. Any questions? Any questions? I'm disappointed that there are no questions. Go ahead. Thank you. Sorry? Sorry, I still didn't get you. Yeah. The configuration file defines the infrastructure and the container image that needs to get deployed, right? Because it's using Knative and the platform has already been set up, it only defines the config YAML is very, very small. It only defines a Knative service with the container image that needs to be deployed. Yes. It's auto-generated by the platform. Tap generates. This sample doesn't take any configuration. So if I need to update configuration, where I created the PR for the delivery YAML, I can add additional configuration over there.
So if you need to update, how do you update it?
You download the delivery YAML, add whatever configuration you need over there as part of reviewing it, and you can generate a PR, and it will automatically get merged back. Any other questions? OK, thanks, everyone. Thanks for your time.